algorithm. Okay, it is always your dividend. Wait, my pencil too thick. Okay, your dividend equals to divisor times quotient plus remainder. But remainder sometimes is non-existent, so it depends. So this is the algorithm that we know. If ever during exam you forget, right, then you remind yourself that when you want to find 10, it is 3 times 3 plus 1. So you just have to use numbers to orientate back to the formula that you can get. Okay? So first thing first. If you do long division, like what you do here, very tedious and fast. So I divide by x minus 3. So I will do the dirty work for you. Okay, you don't need to do this, I do for you. So you end up having this, and then you minus 1 of it. So your remainder is 2. Sorry? Oh, very loud. Okay, can. Okay, so if you do this one, you will realize that, I put below. Too loud, huh? Okay, sorry. Huh? Yeah, it's a amplifier, yes. Can. Okay, so if you use this, you divide by x minus 3, you simplify, right? You realize that the remainder is 2, and your answer is 2x plus 1. So they ask you, can you calculate what is f of 3? Then we check. We sub in x as 3, and then you calculate. Okay, what does it get you? So what do you think it gets you? How can we relate this to the long division? That's the remainder. Okay? So actually, if I want to divide by the divisor, which is x minus 3, if I make the divisor equals to 0, I'm substituting x as 3. And then it will get me to the divisor, it will get me to the remainder directly. But why is that so? Okay, it's because if I rewrite this, we know the division algorithm, right? If I were to rewrite this, I will get this.
So if you ask for a remainder, you can just do this.
Yeah. So can you see that when I sub in, this is my f of x. When I sub in my x as 3, what am I trying to do? I'm trying to ensure that this whole chunk get cancels off, and then I can get my remainder directly. So the divisor algorithm helps you to very quickly get to your remainder by making your divisor equals to 0. Okay, so I repeat for the second example so you can see better. So same thing. This is my equation. This is my polynomial, my function. And then they say, oh, I want you to do a long division of this thing. Divide by x plus 3. So I go through the long way. I do my x square. So this is x cubed. Okay, you don't need to do this. I'm just showing you. You have done the practice just now already. Then I bring down my 7x. So I get rid of the first one. Then I'm left with x plus 6. So I just take away one of it. And then I'm left with 3. So my gut feeling is this. I know if I were to make my divisor equals to 0, my remainder I will get 3. So I check. Now question say, can you calculate f of negative 3? Why negative 3 is because my divisor is x plus 3. If I can make this equals to 0, then my divisor and my quotient will get cancelled out. Okay, so if I were to rewrite this, like what we have done just now many times, this is my dividend. I can get it by using divisor times my quotient and then plus my remainder. So how can I get to my answer fast? If I can make this equal to 0, then the whole chunk will cancel out and then I can get my remainder directly. So that's why they say sub in f as minus 3. So if I sub in f as minus 3, this is my f of x. I sub in f as minus 3, I put in okay, if you calculate using your calculator, it must give you 3. So it gives you your remainder. So actually, this is your remainder value. Okay? So these two examples is showing you if you want to find the remainder for all the examples that you have done just now. Okay, let's say this one. Yes. Okay, this is my example. This is my f of x. If I want to find my remainder, what should I sub in as x? 2. Because I need to make this 0, right? So if I sub in f as 2 into this equation, it must give me remainder 0. Go and check. Okay, it will always be true. Same thing, if this is my f of x, what value of x must I sub in so that it will give me a remainder here? Okay, this one is a different kind of problem. Because this is a quadratic, by right you should factorize it, you got 2 values to sub in. And you got 2 different remainders. So this one we will deal with it later.
But then after we factorize it, then we use one of the values.
Yes. And then you have one remainder. Then another value for another remainder. Okay, this one is the complicated one. I will deal with it later. Yes. Okay, because the only way to make this thing 0 is if I sub in x as 2. This one 0. Yes. If you make the divisor 0, this whole chunk is gone. You can get your remainder directly. The divisor? Yes. They will always tell you what to divide. Okay, so which brings me to this, a very quick sample. Let's look at first question.
This one, can I go toilet?
Okay. Okay, let's look at the first question here. If I want to find the remainder for this problem, how will you do the question? Okay, let me just put this here. Okay, listen. If I want to find the remainder for this question, what should I do? Sub in x as minus 1. So what you can do is, you can let f of x represent this equation first. Then when you present your answer, it's easier. Okay, then you sub in x as minus 1. Make this 0. So when you sub in, it will give you your remainder. Okay, it will give you your remainder. So you go and put in this. Okay, if you want to work harder, you can also go and do long division for this one. Okay, then in the end, you also get 6. So during exam, you have 2 options. You can use this substitution way to get your answer directly, or you can use long division and get the final answer. Your choice. Okay, but actually, right, what we are using here is called the remainder theorem. So it's good to cite it by remainder theorem. This is how you get the answer. Yes.
If the question is something like that, can we use the remainder?
Can, but you need to factorize the quadratic first. Then choose one, there will be two different values you can sub in. Yeah. Okay, so this is a quick way for you to get remainder without doing long division. Must you always do long division? No. Focus. Okay, let's look at the second one. It keeps repeating, it's the same thing over and over again. Question 2. Can. What should I do? Let this be f of x again. And then what should you do? Let x be what? 3. So you just quote by remainder theorem, like how you use Pythagoras theorem last time. Then you will write f of 3 is equal to your remainder value. So you sub in. Just calculator only. Raj. Copy. Why are you playing with that? Okay, you will get remainder as 98. Okay, if I calculate wrongly, then you all let me know. Okay, so it's the same old thing over and over again for the rest of the few examples. Can? Yeah. So when it's divided by x, what values of x will you sub in? 0. In order to make the x 0, you have to make it 0. So for part 3, it's just substituting it as 0. Then you can find remainder. Yes. Yes. You can do long division, you can use this.
But then did they specify you must do the long division?
Rarely. Yeah. Yes.
In question 6, they will give it.
Okay, we will get there. Okay, so this one, I just highlight for you. This one we sub in minus 1. Okay. This one is f of x. We sub in 3 to find your remainder. Okay, I just give you the method. Okay, then this one, like what we say just now, we will sub in f of 0. Sub in x as 0. Then you can find the remainder. Okay, those who have calculated, what's the remainder for this question? 3? Or haven't calculated? I calculate. Square 7 times 0. Okay, you will get 30. Okay, so the remainder for question 3 is 30. When it's divided by x, is substituting 0. Okay, then this one? Yeah, substituting 4. Okay, what about this one? No, you set this to be equals to 0. It's still x equals to 4. Yeah. Okay, what about question 5? What should you sub in? 1/3. So just always make the divisor equals to 0 and sub in the x value. Okay. So can you calculate the remainder for me? 3 minus 8 square times 4 cube plus 20 times 4 plus 20. Okay, is it 8? I'm not sure if I'm right. You double check. Sub in as 1/3. To the power of square plus 36. Okay, this one I get minus 5. Okay, you double check the substitution, see whether you get it. Okay, then 5, 6, 7, 8, 9 is a bit different. They have unknown values inside your expression. Okay, they have unknown values inside your expression. And then divisor is not a constant number. So this is slightly different, not your usual question. Okay, but the approach is the same. So I'm going to show you question 6. Okay, question 1, 2, 3, 4, 5. Can you just double check that the answer is correct, okay? Because it's just substitution, I don't think we need to go through. This is 30. Okay, I will just do the last one, question 6. Okay, I know your brain died already. Okay, but let me just complete one so that when you go home, you know how to do the rest. Okay, this is my f of x. Question 6. This is my f of x. I let it be f of x so that it's easy to represent my answer. It leaves a remainder of 4 when I divide by x minus 2. So what is the value of x I should sub in? 2. And then it gives me my remainder 4. This is what the question tells me. They straight away tell me my remainder is 4. So this is by remainder theorem. So I will do my substitution into the equation. So when I see x, I change to 2. Then it is just solving algebraic unknown. So you just solve for A lor, that's all. Okay, so it looks like it's very scary, but actually it's just all algebra.
Oh, and then you get
Yeah. So instead of you finding the remainder, there's an unknown in the expression, you solve for the unknown, that's all. Okay, so same thing for this one. They give you remainder, but you need to sub in x as minus 3k. Doesn't matter, just sub in and then solve the expression from there. Okay, so you go back and then you try. Okay, I know today CCA day, you do what you can. Anything you can't do, we do in class tomorrow. Okay, not homework, but if you can, just practice at the side. Tomorrow we will go through. Let f of x be the expression. So always let it be f of x first. If you like g of x, p of x, up to you. Okay, but define it first. And then they say when it is divided by x minus 1. So which means by remainder theorem, what happened to this? What is this thing? Oh. Okay, by remainder theorem, the remainder I get from substituting 1 is twice the remainder I get from substituting x as minus 1. So this is the statement I want to see. So I sub in 1 now. Okay, so this is the working you can show. Okay, so that's the working for question 9. So the only thing that is different is this statement, and it's translated from this one. Wait, 1, 2, 3, 4. 4 marks. Okay? Can or not? Can Okay, let me take out these questions. Okay, I'm not going to show you the details of the working for the 4 practice questions here, but I'm just going to run through. The steps. Okay, so you know how to manage the question. Okay, let's just look at the steps of handling question 1. Okay, it says I have this expression and it leaves a remainder of 2 when I divide it by x plus 2. So what you can do is you can let this be f of x. Okay, for this question. And then by remainder theorem, okay, I write short form, you don't write short form. By remainder theorem, when I sub in x as minus 2, it should give me remainder 2. So when I put in 2, I get 4h plus 2k minus 4 equals to 2. And then I get 4h plus 2k equals to 6. So if you want to simplify, it is just something like that. Okay, so you can stop it here first because you don't know what the question wants you to do. Then it says, can you find the remainder of this other expression when it is divided by x minus 1? So you can let this other expression be g of x, for example. Okay, so let this be g of x. Then again, by remainder theorem, g of 1 should give me a certain remainder that I don't know what it is, that I'm interested in finding. So I'm going to just plug in 1. Then you look, you get 3, 2k, 4h, plus 5. So finally you get 4h minus 2k plus 8. Then how to stop there? The question says, can you find the remainder in terms of h only? That means they don't want to see k in your answer. So what you do is, you will make use of this from the earlier part. You make k the subject. So from the earlier part, you know that k is 3 minus 2h. Then you sub it in here. Then you can find your answer in terms of h. So final answer, you get 8h plus 2. Just like that. So this is the remainder for first question. I accidentally solved it. Okay, so no matter how they phrase the question, you just need to know that you just follow the instruction and see what they want. Okay, so that's question 1. Question 2, there will be 2 equations that you need to solve. First of all, you will let f of x be the expression. Okay, I'm not going into the details of the solving. You can solve it on your own later. So just let it be f of x. This is always the first step. Then by remainder theorem, I will write RT lah. Okay. When you divide it by -1, your remainder is 7. So this is the first equation you will get.
Is this the same question as question 9?
Similar. The top part you want or what? You want the top part? Can. Okay, so you will form one equation when you sub in x as -1, and then you form another equation when you sub in x as 2/3. So using the 2 equations, solve simultaneous. So this one, I'm not going through. You can try it on your own. This one, you just solve simultaneous equation. Okay, I will work out all the solutions for this question and upload on Google Classroom. Okay, you can slowly check. Why? Okay, so that's question 2. Question 3. Let f of x be the expression. Okay, and then it says it leaves a remainder of 3b when divided by this. So by RT, by remainder theorem, f of 1 will give you 3b. This is first equation. Second equation, f of -2 will give you this remainder. So again, you will form 2 simultaneous equations, then you solve. So you go and form and solve. I maxed out the screen already. Okay, so I'm telling you the steps. Okay, but you work out on the algebra yourself, ah. Okay, last question. You sub in 1 and you sub in -3. They give you the same remainder. Then solve. Then go and find the equation and express answer in terms of A. Okay, this is just the steps for question 4. So all 4 questions, you can note down on the steps and then try it at home. Okay, it's all just algebra. Okay, those who came back a bit later, just take note when it's even power, when you root the answer, it's always positive and negative, 2 answers. Can? Okay, this is remainder theorem. We have dealt with questions when we divide and we get a remainder. We just sub in. But what is factor theorem? What do you think factor theorem is?
The factor.
When you say something is a factor means what?
If something times something, and if it's like divide the quotient of something.
Something is
It divides the number perfectly, exactly. No remainder. So factor theorem is like remainder theorem. You will put in the values of x from the divisor, but it will give you a remainder 0. That means no matter what, it will be equals to 0. So that's the only difference. Okay, factor means you can divide that number exactly. When I say 3 is a factor of 12, 12 can be divided by 3 perfectly. No remainder. So when we use factor theorem, when we sub in the value of x into the function, it should give me 0 because there shouldn't be a remainder. It's a factor. So that's the only difference. Remainder theorem, they always tell you what the remainder is, right? But for factor theorem, they don't need to say anything, you know it's equals to 0. That's the only thing that is different. So which brings me to the next part. This one. Okay, this one, same thing. I'm not going to make you do this. We already know that when you do long division yesterday, it was tedious. But I think you also had your fair share of fun. Okay, I just show you, but you don't need to do. A plus 2.
You should just do plus 2.
Wait, I do something wrongly, right?
You should do plus 2 instead of minus 2.
Plus 2?
Because you're minusing, so there'll be
Oh, I should minus 1. What am I doing?
Oh, yeah, minus 1.
Then it's plus 1. Okay. Okay? So you will notice that for the long division that you are doing, right? Your remainder must be 0. This one is the only key thing. Your remainder must be 0. So, which means if I divide this is my answer. And it shouldn't give me any remainder at all. And if I write this as using my division algorithm, yesterday we all figured out that is this one times this thing and then plus the remainder 0. But because it's plus 0, it's as good as no need to write lah. Okay, so how can I get to my answer immediately is if I make this thing 0 and then I will get my remainder as 0. So when you sub in f as half, what you are trying to do is you are trying to make this equals to 0. When you make this equals to 0, this whole thing will cancel out. And what you are trying to find is the 0 over here, which is the remainder by right.
Wait, but we know it's 0, then why are we trying to find it?
Yes, but you still have to sub in the value to make it 0.
No, wait, so what are we trying to find?
We are trying to prove that it's a factor.
We have to do
Oh, okay.
No need to do quadratic. Okay, so this, in this case, when you calculate, right, it will always give you 0. You don't even need to sub it in, you know it's going to give you 0 because it is a factor. Okay, so this one, same thing. Actually, you don't even have to do anything about it, you know this will give you 0.
Wait, that's it, that's the word.
Yes.
So that's...
Okay, so this is just an activity to help you see the connection, but the real question is behind. Can we look at the next page? This one. They ask you whether this number or this is a factor of this expression.
So wait, is it just bracket x plus 3 bracket x minus 1?
Yeah. Okay, so first of all, how do we check? We will let f of x be this expression first. So how can I check whether it is a factor or not? I sub in, right? I'm going to sub in x as 3. And then I check if it gives me 0. So I will sub in x as 3. And then I use the calculator and calculate. Can someone press the calculator and tell me what the value is? Okay, can you key into the calculator and tell me what the value is? Is it 0? Okay, so if you find that the value is 0, then you can tell me by factor theorem. Since f of 3 is 0, therefore x minus 3 is a factor. Okay, next one you can check is you sub in minus 1. Does it give you 0?
Why is it minus?
Because you want to make this equal to 0, so you have to sub in minus 1. Okay, double check. Does it give you 0? Is what? Minus 20. Okay, so for the second one, after you sub in minus 1, you realize it doesn't give you 0. You can write it's not equals to 0. So since f of minus 1 is not equals to 0, by factor theorem, okay, x plus 1 is not a factor. Okay, later we'll come back and continue with this
Just plugging it into the calculator.
to check whether it's a factor or not.
Easier than
So if
Yes.
if there's remainder, it's not a factor.
Yes, correct. So no matter what, you have to plug in the divisor and check whether you get a remainder or don't have. Okay, so later we come back and continue. I still have one period later. I thought I could start cubic today, but looks like maybe not. But we will see how. What lesson is it now? Oh, chemistry. Oh, chemistry is always after math, is it?
Yeah.
Seems to be.
I think it's like
Hi-fi Grace.
And then there's math after chemistry.
Is it? Okay, see you later.
Natural science, you must erase the whiteboard.
Hello, morning. Is this Brandon's father? Yeah, I understand from the office that you need me to return your call. Yeah. They will get back tomorrow. Yeah, then they will bring it home. Yeah. Yeah, thank you, no problem. Bye-bye. 么？
更死right actually 比我们更惨，我就来哦，that's bad. That's my only way.
呀，这样更惨。哇，很 disruptive，因为你进去叫不到什么，就已经要时间到了。
是 not so bad. 我跟你讲，
什么？
Justin 我的，I'm back. 你 his usual self 啊。Justin, I'm just wondering why your hair is more brown than me. 然后全部人笑哎，因为他的头发 sorry 啊，真的太 brown 了。
他染的咩？我不觉得
他绝对
嘞
不。是这样的。
Is it？
那男生他们在笑，我讲 you should think his hair is more brown than mine.
他真的染咩？
他没有否认。
我从来没有注意过他的头发，
你要不要抓
因为
一下
本来就是 OK，我跟他讲，我跟他的 guardian 讲，
这太 obvious 了，因为如果一点点我就算了嘛。
我就是跟他 guardian 讲就好了，因为我懒得跟
我 check with him first 啦。
我懒得跟 Justin 讲，没有他的 guardian 也拿他没有什么办法的啦。I just let 他的 guardian know。
他就一直笑，一直笑哎。
哇，他也是一个
好笑了，好笑了。
啊会 lift up 那个班的心情的人了。
我讲 I'm a bit sad because how come your hair is more brown than mine? 他就怕。But it's okay, I'll talk to your form teacher.
他是 survivor 啊。
I'll let your FT know and ask how come you're like.
你可以跟另外一个 FT 讲嘛，不要跟我讲。
可以，我跟你讲，可以。I mean that's it. I mean it's boys right, you can deal with it 啦。像我 text 他。
不要啦，他接 MC。
哦 ，OK。
我跟他的 guardian 讲，嗨。
不要跟他聊一聊先咩？
不要。
你这么确定是 brown 啊
我跟他讲丁
？You
特啦。
see in the morning？
没有他，我跟你讲，我本来都觉得他有一点点那种
有
阿毛色
这个
的，
太 uniform 了。
就好像 Jamil 我也不会什么管他头
Jamil
发
OK
，but 因为 Justin 他每次也是一下，我从来没有看过他黑头发的嘞。
然后嘞，这个是
But Justin 有黑头发过没？我没有印象，
浅色吧，没有这个是
是会脱色。You think he bothers to? No, you think he bothers to go and run his hair? He's so lazy.
I think but he's quite vain, don't you think?
Is he? Did he even comb his hair before? 我觉得他前面那一波是打结的嘞。
Style.
No, he doesn't have a style. 他跟他跟 Jamil 是好像没有梳头发的两个人。
然后我就跟Kieran 就讲，就 maybe when you see him at the East Point, maybe he's buying his colored shampoo. Yeah, like 因为我跟他们讲我 holiday 看到他嘛，他在买 shampoo。
我就顺便叫他 have his hair cut this
Oh
weekend.
yes, get his hair cut too. 我在带 FD 啊，他没有反对的。
他没有感觉的，我跟你讲。
他觉得他就很 chill，他讲哦 OK。
那每次就这样，然后我叫他剪，他也是剪一点点而已。他们是这样的。
他摇啦。
But 他摇 for what?
Really surprised.
Who is looking at him?
Yes, he has height 啦 and money. 有钱，
有闲。
钱也是 money。
This Justin，把他 cute 啦，他 cute。他们两个就 I try my best already，他每次我就 OK。
他跟我讲哎，I'm back。气死我，好出来。
Survivor 啊，这种是那种他可能去 Poly 那个 tutorial 的时候，老师一直跟他们讲有的没的那种。你想 Justin 会有个，然后就那种讲骗话，come out with an excuse。对啦，他去年比较闷闷这样，现在开心，现在他有 Jamil as a 朋友，Jamil 也开心多了。
我看比较亏钱没有过，but 他一直我的问题哦，他每次需要 help 才可以回答。
哦。
他真的很 lost。
But they are all lost, you see.
When I ask Jamil a question, right, I'm actually not looking at Jamil. You looking at me lah, yeah, because you're feeding him the answer.
他们 at least 有帮 each other 啦。
有啦，他帮的这么明显，我都
那
听得到。
你有没有觉得南夏现在没有这么 alone？
有
有人会帮他，还是 degree 还是谁？
因为没有睡觉的时候嘛。
就是你没有觉得他像之前这样，没有人很讨厌他，很没有，他比较可以 blend
I
in
think
一
she
点。
finds support in teachers also. Maybe 因为我们没有说很讨厌他还是怎样，so
所以我觉得 OK 了，他坐在那边是对为他好。
我很靠近啊，真的很靠近。啊，she's okay, she's okay. She
然后
got
就 alert 一点啦，alert 一点啦。
那又来不来workbook 啊？it's okay 的，你走吃什么？我就 stand up。
所以愿望也是，我不要紧啊。
我也不想做，我也不想他硬碰硬，你懂吗？Like you just stand, don't need to talk so much. Okay.
然后我好像看我的 lesson time，怎么这样一直 complain？哎，George, you teach us a bit of math first 哦。
我们来继续，我本来要拖拖。
哦，已经在等了。唉，真的是，因为我很多题没有时间再搬过出来啊。我刚才work out 的 answer 要 upload。
我因为想讲那个 Canon Engineer 4点来，
所以真的有问题啦，真的有问题啊。
呀，他昨天我们就懂了。
哦。
我说哦 ，OK，
then 你就 just 没有做 anything about it。
这个要害我不讲，这个人我还 text 他，给他恼。
唉呀，真的是啊，为什么这样多题？For which chapter? Oh, maximum minimum. Okay. Mama still haven't. I think I still got a few weeks before I reach coordinate geometry.
I had to, it was a moment of teaching them that you can use AI this way.
Then they okay lah. Like because they rarely will use it on their own, right? So hopefully now they will do some self-help, huh? Yeah. The exposure lah.
So by factor theorem, oh then of course before that, let this be f of x first. Okay, then you can tell me that if you sub in x as minus 2, it will give you remainder 0. Because you know it's a factor that has no remainder. So plug in minus 2. KH will just be minus 7, I believe. Okay? So you are using factor theorem knowing that it's always equals to 0. Okay, so if it's remainder, they will tell you what the remainder is. If it's a factor, you know it's 0, they won't tell you anymore. Okay, let me pick out the question. Okay, I will zoom in. Okay, yes. Question 1. Okay, we are. Okay, question 1 just now, right? Take note, it's a determine question. Determine question is like a show, a prove, a explain. So you do not use factor theorem until you prove it. So you can let f of x be the expression first. And then you check. If you sub in x as 3, what will it give you? So this one you need to check. You cannot use factor theorem until you have proven it. Okay, so if you have proven that indeed it is 0. Is it 0? 27 minus 5 times 9 plus 3 minus 12. Yeah. Okay, if you have proven that it is 0, then you say by factor theorem, since f of 3 is 0, therefore x minus 3 is a factor. Okay, you are supposed to determine whether it is or it is not. So you have to show that to me. Same thing, you repeat the same thing for f of minus 1. Plug in. Okay, and then you calculate. Which is minus 20, not equals to 0. So same thing, Since f of minus 1 is not equals to 0, therefore x plus 1 is not a factor. Also by factor theorem. Okay, so you need to write the concluding statement to tell me it is or it is not. This one is page 10, page 10. Okay, so question 1 just now we went through already. Just make sure it's a show question. Yes. We need. I did not. Need let f of x be equals to this. Okay, always define. If they define for you better, but if they never, you define first before you use. Because if you don't define here and then suddenly here got f of minus 2 is weird. They don't know where it came from. So you have to let it be f of x first before you can use it here. Okay, so define your expression or your polynomial properly first. Okay? This is okay, I move to 3. 3 is the same example as 2. Let this be f of x first. Define it always. And then they tell you it is a factor. So you straight away can use factor theorem. So by factor theorem, okay, you know that if you let x be 2, it will give you remainder 0. So with that, you sub in and you solve for h. Okay, 2 possible values of h. Equals to 0. Okay? Can Okay, I realize 4 and 5 is similar. It's very easy. So I'm not going through 4 and 5. I rather go through the next practice question 4. Or should I go through 3? Okay, maybe I do 3 first. Okay, so these 2 you do on your own. It is similar. There's no trap. There's no new routines. So I'm not going through that. You can go home and practice. I will work out the full solution for you. Okay, let's look at 3 now. This one. Okay, I want to go through some of this. Not all, I'm just going through some of this. Because the context is new to you. Okay, wait . Okay, let me look at 3 first. Just 3. Okay, let me pick out this question. Okay, just 3 only. This is from practice question, not the basic ones. Practice questions 3. Oops. Okay, it says that given that x minus 1 is a factor of this expression, okay, fair enough, you know you use factor theorem. So let f of x be this one first. That's the first step, standard one. And then you use factor theorem. F of 1 is 0. So this is your first step. So it will get 8. 3 plus 5 minus 4. So 4 plus h is 0. So h is just minus 4. Okay, very easy. Nothing different. Okay, but what is the different thing here? Is that they want you to factorize the expression completely. This one. They say, oh, after you find h, can you help me factorize this expression completely? So meaning if you see this being a cubic polynomial, by right, if you can factorize it completely, it should give you a product of 3 linear factors. If you can factorize it completely, you will have 3 linear factors. But sometimes it might be a linear with a quadratic. So when they say, can you factorize it completely for me? You know that one of it is x minus 1. Your mission is to find out what is the other 2 that I can get. So how do you think you can get that out?
Divide x by x.
So do your long division. So this is where your long division comes in, and you want to break the expression up to find the quotient. Yes. Cannot, because there's method given to long division. You cannot use calculator and give me the 3 final answer. Long division 2 marks, final answer 1 mark, plus the first part can go easily 5 marks. So if you use calculator, you only get 1 mark for the whole question. No. You don't anyhow mental. Okay, so using long division, you get rid of the first term. So this one, die must practice. So 8x squared, bring down your minus 4x. Get rid of your 8x squared. Okay, bring down the minus 4. If everything is correct, you shouldn't have a remainder because it's a factor. So if this one is not 0, you know somewhere you have done something wrong. Okay, so that means these 2 brackets that I have here is this quadratic. Then you need to check whether you can factorize it further. So actually you know you can. Okay, so this is your factorize the expression completely. Your f of x is actually this 3. If you tell me that it is this, okay, if you write f of x is this times this, then you don't get the final answer mark yet because it's not factorized completely. Okay, you need it to be completely factorized. So need to break it further into these 2. Okay? So usually you can have 3 linear factors, but sometimes the quadratic here cannot factorize anymore. Then it's 1 linear with 1 quadratic. Okay? So I want to show this because this is 4.3. Okay, this thing that you are doing here is 4.3. Is what we are learning for 4.3. You are solving cubic polynomials. So when we solve, when you equate this thing to 0, then x is 1, x is 2/3, x is minus 2. That's all. Okay, so actually this one, why I want to do this question here is because in 4.3, they will give you a polynomial at the start, cubic one, and then ask you to factorize it, and then solve it. Whole question on its own. Okay? but it's all linked. Okay, so that's question 3 for you. I uploaded the... this one, yes, I will. Okay, next one I want to go through is 5. 4 is similar to 3, so I won't go through. I want to go through 5 because they give you a quadratic factor. Okay, so I want to address the quadratic factor. So I'm going to go through 5. Oops. Okay, let me bring this 5. Okay, let's look at practice question 5. It says that this quadratic expression is a factor of this polynomial. So no matter whether it's quadratic or linear, we let it be f of x first. Okay, then usually we will sub in values of x such that it will make the equation be 0 with remainder 0. So what values of x can I sub in? What do you think I should do? Can I factorize this quadratic? Can, right? It will be x minus 2, x minus 3. So actually this quadratic is made up of 2 linear factors. When I say I can divide by this, when I say an expression is divisible by this, right? It means on top of the expression, I must be able to simplify. But it also means that if I break this into 2, I should also be able to cancel them separately. Right? If I can simplify the whole quadratic, I can simplify with the individual factors. So if it's divisible by the quadratic, it is divisible by its individual factors. So I can also, using this, say that by factor theorem, f of 2 must give me 0. Form one equation. Then the other one is f of 3 must give me... Okay, this one is minus, right? Did I write something wrongly? Yeah, minus. Okay, so this one is also give me 0. So we go and form 2 equations from here. One is 16. No, 32, 32 plus 8h plus 4k plus 40 plus 12 is 0. So 8h plus 4k is 40, 12, 32 minus 84. So if I divide by 4, it's a minus 21. Okay, same thing here. I put in 3. 3 to the power of 4 is 81 times 2. 162 plus 27h plus 9k plus 60 plus 12. So you can form 2 equations. Plus 162. So 3h plus k. Okay, so these are your 2 equations. 1 and 2. Then you can solve for your h, you can solve for your k. So if I subtract the equation, second equation minus the first one, h is minus 5. Okay, and then k would be plus 10 negative 11. Okay, something like that. Okay, so even if I give you quadratic factor, don't be scared. Factorize it. Each of the linear factors are factors of the expression. Okay, so with that, how can I factorize the polynomial completely? Sub in the h, sub in the k, and then what do you do? Do the long division. So you put your original equation in 2x4. Okay, you double check in case my h and k I count wrongly. It happens. Minus 11x squared plus 20x plus 12. Then you go and divide by this. Okay, do your long division, then you can get your last linear factor or the last quadratic. So 2x squared. Okay, it is tedious, but it is worth your effort because it is 5 marks. What? Not worth it?
Should be 10 marks.
So greedy. So no need to think, you just work only, just work. 23x squared. I think so. Then 20x. You see, just carry down. No brain work.
One mark per number.
Too much. 630x. So this is 2x squared minus 10x plus 12. Okay, the very last one is just a 2. 2x squared minus 10x plus 12. Okay, should give you remainder 0. If not, something is wrong somewhere. Okay, so the final factorization of the expression f of x is your quadratic factor and the quotient you find on top. 5. So if you look, because they say must factorize completely, right? You check, this one cannot factorize anymore, then you leave it. But this one, you can factorize, so write it this way. So your final answer is this one. Sorry? We need to factorize it so that later, in the later part, when we solve it, it's easy. This will be equal to 0, this will be equal to 0, this will be equal to 0. Yeah. Yes. This kind of question can come out for WA. O level likes this kind. Yes. Okay? Okay. So, right, the remaining question you try on your own. What was the one I circled? I forgot already. All the remaining question 1, 2, 4, 6, 7, 8. Okay, go and do on your own. Example here, they ask you, can you factorize this for me? They say factorize this, right? Then using the sum of cubes above, you can factorize it easily. Because this would be, what is the answer that you will get? So x, 2, x squared, 2x, and 4, right? Because this is a squared, ab, b squared. Okay? This is a, this is b. A cube plus b cube. This is your a, this is your b. Can you see the a's? A is your x. Okay? B is your 2. So if you just put in your values, then the sign will follow so. Same sign, opposite, always positive. So your factorization is just like that. Don't even need to do long division, don't need to do anything. When you see sum of cubes, you apply so. When you see difference of cubes, these two, Okay, when you see difference of cubes, this 2 is difference of cubes because what is this? This is 4x cubed. What is this? This is 3y cubed. So using the SOAP property, it will also be a square, not a square, a, right? A, b, a square, ab, and b squared. Okay, so the rest will be same sign, opposite, always positive. So your factorization will naturally become this 16x squared, 12xy, and 9y squared. Okay, that's all I have to say today. Okay, so remember your SOAP, ah? You apply actual SOAP, then the paper will tear. No, the